okay, we take R by D, okay, we take steam to feed ratio, okay, we take pressure, okay, we take different temperatures also.
I mean,
Okay.
sorry, you mean this, right?
Yeah. No, I'm just these inputs, okay.
This.
But let's just try to understand how do we sort them out as
Yes.
another. So we take all the lab samples,
Last sample,
okay.
yes.
And before that, what we do is your toluene sample is taken from here, right?
Yes.
Sample point, okay.
Yes.
So if you take sample at 8 a.m., okay, this may be the result of this temperature or overall column performance from 7 a.m. right?
Yes.
Last 1 hour, last half an hour, correct? So what we do, we create averaging of this temperature, reflux ratio, reflux to distillate, steam to feed, pressure, all feed and all. So that 8 a.m. sample or lab value is equivalent to your average of TI from 7 to 8 a.m. Okay, so what we get is one lab value, one average.
Yes.
So similarly, we'll get average of R by D, R by F, and so on. Okay, whatever number of parameter we take. Okay, fine.
Yes.
So we get toluene of, let's say toluene is 0.1, we get one temperature, Ti1, TIC1, RF 1 value, R by D 1 value, S by F 1 value, and pressure as 1 value. Similarly, if we have value as 0.05, then we get Ti2, TIC3, sorry, TIC2, RF2, RD1, RD2, S by F2, and pressure 2. Okay, so we have for each sample we get different values. Okay, now what we do, or what software does for us, is so first is this like data what you say massaging, okay, that we do. Okay, next what we do is we take scale, okay,
Yes.
we plot lab value, okay, so lab value, and then these first TIC. If there is a relation and temperature is increasing, it should look something like this, right? Net, when temperature is increasing, my bottom benzene and toluene would decrease, right?
Yes.
Correct?
Yes.
Similarly, this is TIC for R by F. Same trend. Lab value for benzene toluene, okay, and with increase in R by F, it will also have something similar, right?
Yes.
Okay.
Yes. The relationship between lab and
Individual parameters. Each individual parameter we will have
Individual.
trend. Okay. Now with this trend, what we can calculate is, okay, for each change in lab value, how much is the change in TIC? Okay, we calculate this ratio. Let's say we take this value, okay, and this value. So lab 2 minus lab 1 divided by TIC, right? These would be TIC C2 minus TIC 1, okay, and we get that value, which we get
PI.
this value, okay. This gain we called as gain,
Yes.
okay. But this is just like, because we have so many samples, we get one gain, okay, for TIC.
Yes.
We also get gain for R by F, okay. Okay, we also get gain for R by D, R S by F, PI, okay.
Single.
Yeah. So no, I'm just putting as of now, just to explain that may be different because each inferential will have different inputs. Now first is let's say this is very clear case, we are getting good relation, okay? But some cases what happens, lab value and your parameter which you consider, okay, does not have any, comes like this, okay? What does it mean? If this parameter remains here, lab value can vary from here till here.
Not correlation, right?
There is no correlation, okay? Or the process does not show any relation with it, okay? Or there may be lab is very narrow, okay? Or temperature is or parameter is very sensitive. There can be multiple reasons, so we don't get any relations, okay? So what we do, if we get, let's say we don't get any relation, we drop this because it is not showing me relation. So what is the point in taking? And only take which shows us some relation, okay? So that's why then we take all of them and then choose which one are good, roughly good, okay? No one will give us exact this kind of behavior, okay? None of the parameter in plant will give, barring one or two cases, okay? Most of them will have somewhat this behavior which we try to improve by some internal calculation, okay? So whichever will have a better this kind of behavior, we choose them as inputs, okay? And the gain comes from, like I said, like this. For each individual, the gain would be there, okay? So this is what inferential is. Now, when we make inferential, this is clear, okay? Say your inferential is now is equal to gain into input 1, okay, plus gain 2 into input 2, okay, and so on. But because this is based on historical data, we took 3 years of data, right?
Yes, 3 years.
We took 3 years of data, correct?
Yes.
This is past performance, but we need to do it for future, right? So what we need to have is, we need to correct it always with the lab value, the upcoming lab value. Some inferential may be excellent, okay? Some inferential may not be that good, okay? That's why for benzene toluene, I'm saying if we are able to maintain less than 0.5, then we would be good inferential. If the value goes beyond 0.5, maybe we'll need something else to look at, okay? We may not be very sure about it, okay? So depending on inferential types, it will change, okay? Fine?
Okay.
Yeah.